Okay, the next presenter is again Tom. Tom's going to talk about an educational Cubesat that can be used in the classroom for teaching and to get the kids interested. Tom, should be very interesting.
I'm just looking for months to stay in the house. Can you just
Can everybody hear me?
Yes, sir.
Take this off. It is on.
Turn it up.
Talking too softly. I'll try to talk a bit louder. Okay, so what I'm going to talk to you about in this presentation is educational satellites. So I'm a big believer in the space travel, space research, satellites. It's definitely the way of the future. And currently in South Africa, according to me, is unless you get to the university level, there's not much else to learn along the way in terms of working with satellites, working with the dangers of space, etc. So this is just a little side project we have been experimenting with, trying out different stuff. We do a lot of high altitude balloon launches, so it seemed like a perfect platform to test these out. So the main reason is, like I say, it's for educational use. It is a work in progress. This isn't a finished project. The basic idea is not just to create a model of a CubeSat, but to have something that actually simulates it, so a whole CubeSat simulator. Also, it doesn't actually have to go to space, so it can be a lot cheaper than an actual CubeSat. And then eventually the next step after this would be to simulate not only the satellite, but to create some kind of way of simulating the space environment. So, like I said, why? Lots of CubeSats are being launched at the moment, lots of universities, private groups. A lot of these satellites are dead on arrival because space is hard. It's just one of those things. So I want to bring satellites into the classroom, start them at a very early age, and also promote interest, especially in South Africa, in getting more people involved in playing with satellites, doing CubeSats, etc. So the first one that I started playing with is the CanSat. Now the CanSat idea is nothing new. The universities essentially took a soda can, a Coke can, cut out the side, and then built the electronics inside. Unfortunately, Coca-Cola messed that up recently by changing all the can sizes and making them small. So it's getting thicker. So what I did was I did a little 3D printed design of a type of CanSat that is based on the Coca-Cola soda can. It was originally designed for rocket launches, so you would put it in an amateur rocket and then launch it, and it would eject it at about 100 to 300 meters up, and then it would basically come down with a parachute. So the idea is pretty much the same, except that I wanted it to be something apart from the 3D print. The rest shouldn't be custom. So the whole inside of the CubeSat, nice little screw top. Got a little insert, and you can mount electronics such as a Raspberry Pi, Arduino, etc., all off the shelf components. So this gives us various ways of launching it. One way being in the rockets like originally, alternatively putting it on high altitude balloons, or even because it's so light, you can even make a little release mechanism for a quadcopter and just release it there. So in essence, it makes experimentation just so much easier for a classroom environment, cheaper and more accessible. So yeah, the whole design is basically a little designed in Fusion 360. The whole idea is to make it all open source, so that any classroom teacher, student, whatever, can basically take the designs, modify it according to their needs and whatever sensors they want to put in. So there's some nice big pictures of it. The limit switch on the side is basically for the release mechanism. If it gets, it's basically off until it's released out of a rocket or a quadcopter or a balloon, and then it will basically turn on and start either transmitting or collecting data. The second, after this works quite well, and we've been playing with this, but obviously you want to make something more realistic. So the second phase of this that I'm started working on is a more realistically looking and workable Cubesat design. Obviously not something that would go into space, but something that is easy to build and affordable to build in a local environment. Currently I've got the transceiver board done, or a first version of it. The next couple of boards it's going to get done is the main controller, the power board, an experiment board, and then obviously we want to launch this on a high altitude balloon, so we're adding stuff like GPS and other sensors which wouldn't typically be found on a Cubesat that ends up in space. So the transceiver board that originally started, it uses one of those cheap DRA 818 modules. You can take the UHF or the VHF version. It's currently set up to basically, whatever other boards plugged into it can just send the information over the I2C or over the UART setup, and it will basically build up little AX25 packets and transmit it, similar to what the APRS works. It's got a little connector, a universal connector that will be between all the boards to basically daisy chain them all together. And with this board, it can send data and receive data, which can be decoded at the ground station. That's the first one that I finished, so I've got one. Where did I put it? So it's basically board number one. So I'll put it at the back there, you guys can have a look. So it's not perfect engineering, it's not designed to go to space, but it is relatively affordable to basically put it in a classroom environment. The next board that I'm working on currently would be the power board. It's going to be a board that has connections for solar panels, does current measurement, it's got your basic solar panel controller and charge management, and it will basically distribute the power to the rest of the AGSat. The main board will be a controller, nothing fancy. I'm trying to make it Arduino compatible. Now, I know not a lot of people are fans of the Arduino, but realistically in a classroom environment, that's what the guys know, that's what the teachers are being taught. It's maybe not perfect for actual space-going satellite, although there was an Arduino satellite that ended up in orbit. But for the classroom environment, to teach the ideas around satellites, this is a good option to do. Then obviously I want to make an extra board that will make it easier for high-altitude balloon launches. So it'll have a GPS interface for release, and then various I/O that can be triggered from the ground station for initiating experiments, etc. So yeah, like I say, the goal is to create various solutions to bring satellite development into the classroom. I'm big on the idea that it's definitely the way of the future. It's a good way of promoting the interest in South Africa. There's a GitHub where all the files, as I figure stuff out, will be going on there. It's a work in progress. I'm still learning myself. We did have interest from VUT in Bell Park. They're keen on playing it there as well. And then the little CanSat kits that we made by Shop, it's a little shop there in the clip. They also want to make little kits and basically sell it there to get more people involved. And yeah, that's my little side project. Any questions?
What kind of power is your transmitter got?
What, like the transmission power?
Yeah.
You can set it between 1 watt or half a watt. It's set to half a watt. Just trying to keep it as low as possible. The alternative, the other idea is, because not all schools necessarily have amateur radio licenses, is to make a similar board but with some kind of LoRa interface on it.
Which are the frequencies you're looking at here?
Well, because of the way the DRA module works, you can either put on a VHF or UHF one, and it can be programmed into there. So there's no fixed specific frequencies. Obviously, these guidelines that need to be followed to just keep it in the right band thing. Okay. Thank you very much.
Thank you, Tom. A very nice, very simple toy to play with.